Good afternoon, everyone. I'm Ken Amron, and this is a continuation of our video series. This is part 3, and today I'm going to share with you a case study on Larry the golfer. Let's meet Larry the golfer. Let's just say his golf game is erratic, and he wants to play more consistently. For the measure phase, what is the output of Larry's golf game? The specification. Larry wants to shoot between an 80 and 100 this season with a target average score of 90. A professional golfer is going to be shooting in the low 70s. So you could see as far as with what Larry wants to achieve. So first thing is we have to determine what is Larry's process capability. How does this relate to his long-term and short-term golf game? And the goal is to reduce the variation and move the average of Larry's golf game. How do we determine the opportunity for improvement for Larry's golf game? This means just by improving his control, he can achieve a 5.5 sigma gain. If he wants a 6 sigma gain, he will also have to improve his skills. Let's analyze his game by breaking down his score. Where's the biggest opportunity in his overall game? He takes more short shots than long shots in his game. 62.3% of his shots is in his short game. Let's continue to break it down further. Where the biggest opportunity in his short game? He takes more shots in his putting game, 66.9% versus chips. Next, let's prepare a fishbone or a cause and effect diagram on Larry's putting game. So now if you have any ideas as far as with this, please feel free to put it in. So here is the results as far as with our fishbone diagram. For the measurement, Larry could cheat at counting. He can't remember. His pencil has an eraser. For the material, it could be the grass type. For Larry, it could be the number of drinks that he had on the golf course. His eyeglass prescription needs updating, or was he properly rested from the night before? The environment could be the golf course, the green conditions, the time of day, the weather, his playing partners, and whether he was betting on the hole. The methods include his putting style, which includes his stance, grip, and swing, and how well he's accurately able to read the green. The machine includes the putter type, the ball type, his shoes, and his gloves. Is putting a significant source of variation in his overall golf score? Yes. Based on the scatter plot fitted line regression, the R-squared value says that 90.6% of the variation in his overall score is directly related to his putting game. Let's figure out what's causing the variation in his putting game. Based on a run chart of Larry's scores, what did Larry do differently in this time frame? If he gave up drinking, does the number of drinks directly affect his putting game? The R-squared value says that 87.2% of the variation in his putting is directly related to the number of drinks that Larry had on the golf course. Conclusions: Larry should putt or drink but not do both. If Larry gives up drinking while golfing, he would have addressed 87.2% of the variation in his putting game. By bringing his putting game under control, he will achieve a 5 sigma game. To achieve a 6 sigma game, we will have to do further investigations. Next, let's review the improve phase. Last time we determined that the number of drinks was a significant X. What other scores are also driving his putting score? In order to improve his game above a 5 sigma level, he has to improve his skills. What skills does he need to improve? After talking with Larry and the golf pro, we have concluded that there are 3 areas that would be most likely to improve his putting game. They are the putter type, his stance, and his grip during putting. The golf pro wants to sell him the latest high-tech, high-dollar putter, such as a Big Bubba. What does Larry have to do? Larry was not sure, so he consulted with his trustworthy black belt who used the data to help him make the decisions. They set up a design set of experiments with the following settings: putter type, stance, and grip. This is the experiment matrix that they decided to run. This is a 2 to the third DOE, which has 8 conditions to test. In this experiment matrix, after we randomized the order to ensure that they will run. And the key thing is with the DOE is we want to limit the number of factors that we are testing. We ran the experiments and these are the results. The stance and grip are significant factors. This has been verified statistically. The closed stance with the interlock grip gives Larry the lowest score. DOE conclusions: the high dollar putter made no difference. The interaction between the closed stance and interlock grip gives Larry the lowest score. Just using the interlock grip or the closed stance by themselves will not achieve the lowest putting score. So, what is Larry's improvement plan? Give up drinking on the golf course? Continue to use old reliable putter since the DOE showed that the Big Bubba putter made no difference? Always use an interlocking grip and close stance when he putts? Let's implement these improvements and collect some data. Larry, it's time to play some golf. Has Larry improved on the golf course? Yes. How much? From the measure phase, he went from 820,000 defects per million opportunities to the improved phase where he went to 12 defects per million opportunities. Next, let's review the control phase. Larry needs a control plan. What's a good plan to ensure that Larry sustains the improvements he has made? Are there risks that could cause Larry to lose his improvement? If so, how should Larry address those risks associated with changing his golf game? Can Larry come up with a realistic drinking objective and maintain his improvement? So, what's Larry's control plan? Alternate drinking plan? Leave the wallet in the car. He only takes enough money for one beer. Lock and put a key on his partner's beer coolers. Have an unlimited supply of fake beer. Don't tell Larry. Put a label on his putter where he always sees when he's putting, interlock grip and closed stance. More on Larry's control plan. The SBC control chart. Use a mean plus or minus 3 sigma limits as calculated from the improved phase data. Continue the data collection on the vital X's. Let's start tracking the number of drinks that Larry had on the golf course. Okay, he's got a plan. Are there any risks associated with it? Let's perform a risk assessment. We identify the risk elements, which include the schedule, cost, and technical. Assign ratings, high, medium, and low. Prioritize the elements, the probability and impact. Identify a risk abatement plan. Incorporate into Larry's control plan. Giving up drinking is a risk. We need an abatement plan. For abatement planning, if Larry can drink moderately, can he maintain an improvement? The linear regression predicts that 1 or 2 drinks will only add a few putts. Monitoring the SBC chart. What happened here? According to the control chart, he shot a 99. It's out of control. Let's look at the data. Larry had 4 drinks on the golf course. Larry, I guess, got trashed that day. Was there a risk assessment, abatement plan? Yes. Is there abatement plan? Yes. Then let's implement the abatement plan immediately. Stuff happens, so we do risk assessment abatement. Did the abatement work? Yes, according to the control chart. His capability analysis says yes. He has reached 5.7 sigma. Success.